Hi everybody, my name is Doug Davis. I'm the offering manager for Knative and I work for IBM. And today we're going to be giving a very quick introduction into Knative, a new platform that lets you run serverless as well as other type of applications. All right, so first let's get right into it. However, before we actually talk about Knative and serverless and stuff like that, I want to talk a little bit about our history in terms of how we got to where we are and give a little bit of background in terms of explaining why Knative is so important going forward. And to do that, first let's talk about cloud native technologies in general, and in particular why we're looking at cloud native. And I think things kind of boil down to two main reasons. First is this whole notion of breaking up the monolith, right? Take your large application, break it up into smaller little pieces, in particular microservices, so that you get better resource utilization, and that way you can get reduced cost as you manage your infrastructure, right? It also, of course, allows you to do all the other things that go along with that. Things like you can scale parts of your application instead of an entire monolith every single time. Again, it goes to better resource utilization, right? You don't have to scale the whole thing when only scaling a small portion of it will do. And of course, it also allows you to focus or have teams focus on particular parts of the application because they can own just a set of microservices and not necessarily have to worry about the bigger picture per se, right? They can have more focused work items. Now, the other side of cloud native is this notion of an abstraction, right? So if you look at the chart on the right-hand side, as we've sort of gone through this progression of working on bare metal to virtual machines to containers, what you'll see is this progression where as a developer or as an infrastructure manager, you start worrying less and less about the underlying infrastructure of the layer below you. So for example, with virtual machines, you stop worrying about bare metal. With containers, hopefully you stop thinking about virtual machines to at least some extent. And of course, as you go further to serverless and functions as a service, you really you care less and less about the infrastructure that's hosting your function or even your container in the container space. And you just sort of say, here's my application, go host it for me, right? And so you get this progression where the abstraction is increasing as you move closer to the right and up. But also the reason you're doing this is so that your developers can focus on running code, not infrastructure. And why is this important? Well, obviously, not only because it allows them to focus on what they really want to work on and not this the sort of the background noise of the infrastructure and managing it, but also because it allows you to get your developers to produce code in a faster pace, which gets you to market faster, which of course saves you money, and you can also then make money faster, right? So there's a whole bunch of things here at play in terms of why we're looking at cloud native and this progression that we've had over time. But of course, with this progression, you now get more choices, right? Because you now have virtual machines, containers, serverless, platform as a service sitting between containers and serverless. Which one do you use, right? And so there are basically three different options available to most people when they think about cloud native technologies, right? We have something like platform as a service, which is what I would consider sort of the first main one that got out there in the cloud native space. And that's something like Cloud Foundry, where they have a very simplified user experience. You basically say, give me your code, I'll host it for you. You don't have to worry about anything else. You just code away, right? No infrastructure management whatsoever. You also have something like containers as a service, Docker, Kubernetes, that kind of stuff. In some ways, this almost moves you back towards the infrastructure layer because you're sort of managing infrastructure, not say at the virtual machine level, but at a container level, obviously, right? So you have to manage containers, the networking between the containers, volumes of the containers, stuff like that, right? So it's a little bit closer to the virtual machine, but it's not quite as complicated as virtual machine or bare metal management. And then you have functions as a service and serverless. And here you have an example meaning OpenWhisk. And here you have something very similar to containers, where it's, or actually some more similar to actually platform as a service, where it's very close to, give us your code, we'll host it for you, we'll scale it for you, all the other good stuff. But as people look at these choices, it's not always necessarily clear when you have to choose one over the other, because there are a lot of similarities. And what I'd like to do now is actually talk a little bit about those similarities. And while we're doing this, highlight some of the things about what is a serverless platform, since some of you may not be necessarily familiar with serverless yet. So let's first talk about platform as a service. I think that's one of the easier ones for people to sort of wrap their heads around, right? So a serverless platform like Cloud Foundry starts off with a very simplified user experience. For the most part, in the Cloud Foundry case, you have a very simple command line, you do a CF push, takes your code, compiles it, hosts it. Very, very simple, not a whole lot of complexity needed there. Obviously, under the covers, in most cases, they do use containers. And it's microservices based. Now, obviously, the thing you push could be a very large application, but you're typically supposed to use it with smaller little components or microservices. So they're dealing with tasks that are smallish in nature. Okay. Now, stateless. This is very important. Because you're running containers, because containers are ephemeral, you're supposed to write your applications such that you don't really persist any state inside your container itself. If you need to persist something, you store it outside the container, inside of some volume someplace out external, or a database or something like that, right? But your containers are supposed to be stateless going forward. Load balancing an endpoint, or an endpoint that you talk to it. That's there. The platform manages this for you. You don't have to think about it at all. Life is good. So build. Most platform as a service environments do a build for you, meaning give us your source code, we'll compile it for you. In the Cloud Foundry case, obviously you can also give it a Docker image if you want. If you have your own build process, that's fine as well. Pay for usage. Now this obviously is only true in a public cloud environment, but there are some environments, for example, IBM Public Cloud, excuse me, where you only pay for the actual instances or containers that you're running for your Cloud Foundry application, which is great, right? So you don't have to pay for an entire cluster of virtual machines if you're only using a small subset of it because you only have a limited set of applications running. Now, on-demand infrastructure. So if you set up your PaaS environment to scale automatically, what it will do is you'll deploy it once, you'll have one instance sitting there running, and as load increases or CPU increases, whatever, it will start scaling it out, meaning create more instances of your application to handle the load. And of course, because you have a load balancer, it will send requests to the appropriate instance as needed, right? Again, you don't have to think about all this stuff. It just sort of happens magically under the covers, and that's all wonderful. Now, those are all the things that something like Cloud Foundry will do for you. Now let's talk about some of the things that might be missing from that environment. So obviously, because it's a simplified user experience, you don't necessarily have access to advanced features, such as network and volume control. Now, in some platforms like Cloud Foundry, you do kind of access, you could get access to some of those if you really wanted to. But it's not necessarily a first-class thing that's presented to you. It's it feels more like an add-on more than anything else. I would definitely say in my experience, it feels more like something that they just sort of bolted on the side because people asked for it, but they kind of grudgingly give it to you. And that's fine, because that's what they want you to try to avoid having to do all that stuff, right? Which is fine. So with that behind us for platform as a service, let's now talk a little bit about containers and functions as a service. So first, containers. Now, containers as a service is similar in the sense that it has very similar aspects to what you saw in platform as a service, right? It's containers, microservices based, stateless, but there are some missing features there, and that's very important. So for example, a simplified user experience. Now, Docker did a pretty good job of making it simple. However, it still exposed you to things like networks and volumes, which is why there's a checkbox in the bottom right-hand corner, right? And Kubernetes is the same way. But of course, Kubernetes, I don't think most people would claim is necessarily the most simple user interface, and especially when you compare it to something like Cloud Foundry, right? But then there are other things like, for example, load balancing and an endpoint that you can use to hit your application. Obviously, they're there, but you have to manage those by yourself. The infrastructure doesn't necessarily do that for you. On-demand auto scaling as well, right? You can set up Cloud Foundry, I'm sorry, not Cloud Foundry, Kubernetes to do that, but you have to do it yourself, right? You have to go out of your way, set it up, and manage it yourself. Now, Kubernetes doesn't have build as another example of something that's missing there, right? You can do builds in Kubernetes if you really wanted to, but you'd have to do it yourself. So there's a slight difference there between platform as a service, containers as a service. Similar underlying technology, they both use containers, both use the network under the covers, but one, platform as a service, chooses to hide most of it from you. Container as a service exposes more to you and doesn't have the simplified user experience. So let's go one step further and look at functions as a service or serverless. Now, functions as a service is actually very similar to platform as a service, as I said earlier, right? Very similar functionality. Simplified user experience, containers, microservices, all that other stuff. Now, I will point out one key difference here, though. While technically functions as a service, it can be viewed as microservices. Many people look at functions as a service as sort of a microservice or an ultra microservice thing, meaning the applications you run there are supposed to be smaller than your typical microservice or component that you run with platform as a service. Think of it more like independent little utility functions, right? Each function is meant to do one particular task very, very well, and that's it. So that goes along well with this whole notion of everything being stateless, right? And what you're supposed to do is sort of string or orchestrate these various functions together that combined will produce a larger application or component for you, right? But each individual function is supposed to be relatively small, even smaller than the microservice. But other than that, for the most part, functions as a service and platform as a service are very, very similar. Now you might be wondering what's the difference between functions as a service and serverless. And in many ways, they're actually very, very similar. And if all you care about is sort of the 30,000 foot overview, you wouldn't necessarily go too wrong if you think of them as almost the same thing. But really what it boils down to is functions as a service is this notion of taking the microservice and breaking it down even further. Where serverless goes one step beyond that and says, well, that's great, you've broken it down, but when it comes to your charging model around how to actually host this stuff, serverless goes one step further and doesn't just offer all the features that we have here on the third column, but it says when you're not using the function, it will scale down to 0, meaning you will not be charged unless the function is actually running. And that's probably the biggest difference between functions as a service and serverless, is serverless implicitly has this notion of scale down to 0 and 0 cost associated with when you're not using it. But aside from that aspect, in terms of the technology that you use under the covers, it's basically the same thing as function as a service, okay? So with that's a very high level of those three. However, functions or serverless does offer additional little features that are important to call out. So typically functions are event driven, right? Meaning because they scale down to 0, they have to be brought back up by something happening. And in that case, what we're talking about here is an event. So some event happens, generates some sort of HTTP message or event that goes over the wire, and that gets delivered to your function. The infrastructure notices that incoming request, notices your function isn't running, and scales it up, okay? So everything in serverless and functions are supposed to be event driven. That way it knows when there are no more events, it can scale everything back down to 0. Now you can do that obviously with container as a service and platform as a service, meaning you can have that your stuff be event based, but typically those environments don't scale down to 0, right? So there's a slight difference there in terms of why that matters. We already talked about this. Some functions and serverless typically scale down to 0, the other two do not. Now there's a whole notion of asynchronous operations. You obviously can set up your platform and container as a service to do asynchronous processing, meaning once the request comes in, you return something like an HTTP 202 so that your client can go on its way and then later on query the result. But those aren't typically built into the platform itself. However, many functions or serverless platforms do have these things built in as a first-class feature, which is really, really nice. Now, let's talk a little bit about what maybe platform as a service has and container as a service has that function doesn't have. Non-restrictive task execution times. By this I mean there are many functions as a service platforms out there that will actually not allow you to run your function as a service indefinitely. Right? They have some sort of time limit, maybe 30 seconds, 5 minutes, 10 minutes, something like that. And eventually they'll kill your function because these are meant to be short-lived little utility functions, like as I said earlier, to get your job, to do one job very, very well, get it done, and then exit, right? Now, when you contrast that with platform as a service or container as a service, right, those things can't typically run forever because you can run any kind of job you want in there. So there's another difference between those two types of platforms. Again, non-restrictive resource usage. Many serverless or function platforms don't just limit the time that your functions can run, but the amount of memory they can use. Now, obviously, platform as a service and container as a service, you have similar restrictions there, right? You can set up your containers to only have a certain amount of memory. You're not going to have unlimited, but typically what we've seen so far for functions as a service and serverless is they have even smaller amounts that they'll allow you to actually provision, right? So they'll give you only a smaller amount of memory, smaller amount of CPU, that type of stuff, as you start writing the functions. Whereas platform as a service and container as a service, it's much bigger, right? And this all goes to why or how the infrastructure is actually managed under the covers. Typically, these functions as a service platforms are in shared environments, and therefore they can't allow you to necessarily eat up all of the resources within that virtual machine or piece of hardware because it's shared among other people. So they have to manage it in a much more tightly controlled fashion, okay? So you have these three choices. There are pros and cons with each. None of them actually do everything really, really well. And my assertion is Why should you necessarily be forced to choose between these three? Because for any one application or any one environment in which you're hosting stuff in, you may want different aspects to all these, right? So why do you have to actually choose any of those three, or choose between one of those three? And that's where something different needs to come into play, and that's where Knative comes into it. But first, before we do that, let's talk a little bit about Kubernetes. Because Kubernetes is really becoming the most popular container management platform out there, right? There were other ones out there, and there still are, but really Kubernetes is basically eating the world. And at its core, Kubernetes is a platform to allow you to deploy and manage your containerized applications. And that's wonderful at a very high level, right? Understand what that is. However, once you start playing with it, you understand that Kubernetes, as powerful and as nice as it is, it's really, really complicated to use, right? I'll look at all these resources that I show here on the left-hand side, right? Containers, pods, replica sets. I'm not going to explain what all these are, but these are all of the resources that you, as a Kubernetes user, have to understand and manage, right? It's no longer this notion of give us your code, we'll host it for you. You have to understand all these various bits, how they work together, and how to manage them. Now, even aside from the resources themselves, you now have to learn a whole bunch of other tooling, right? You have to start learning YAML, because Kubernetes seems to really, really like YAML, or JSON if you really want to, but most people use YAML. You have to understand the way resources are managed, tooling like Helm, the new command line, Istio, the networking mesh, all these other things that are just the tooling that go along with the resources inside Kubernetes, you have to manage yourself now and understand. If you want to do more complicated deployment mechanisms, like a blue-green deployment, you can do it with Kubernetes, but you have to do it all yourself. Other platforms, for example, Cloud Foundry, will help you out in some way there. Okay, so this entire promise of cloud native computing that we talked about earlier, with this whole abstraction as you're moving closer to the right-hand corner of that picture or of that graph, where you no longer have to worry about the infrastructure, it's almost like it's falling apart at this point, right? Because Kubernetes almost backtracks, right? You now have to understand all this infrastructure, and you almost have to become an IT expert all over again, which is sort of backwards to what we're trying to go towards here, right? This whole notion of decreasing concern and control over the infrastructure is no longer true. And that to me feels like a step backwards. So let's go to what people really, really want, right? They just want to deploy their code. They don't want to worry about this infrastructure. And that's where Knative comes into play, okay? So at a very most basic level, Knative is just an opinionated, simplified view of application container management. What that really means is it's a simplified view of Kubernetes, okay? So it allows developers to go back to focusing on writing code by allowing you to leverage the abstractions that we've already know and love from things like serverless, platform as a service, and those kind of places, but using it in a Kubernetes world. Okay, so what this really is it takes Kubernetes, extends it, so you still have Kubernetes under the covers, right? You still have all those wonderful features available to you, but it presents it to you in a simplified fashion. However, if the need arises where you have to go around that opinionated view and get access to more complicated features, because Kubernetes is still there, you can still get to those. And that's the benefit of it, right? With Knative, you get the simplified user experience with the advanced functionality behind the scenes, but if you really want to, you can get to the advanced features yourself directly if the opinionated view gets in your way of doing what you need to do. Now, because Kubernetes is still there under the covers, what that means is you can still run your existing Kubernetes workloads alongside your Knative workloads, and they can interact together just nice, perfectly well, because everything is still running Kubernetes resources under the covers, right? So you still get a single world just with a simplified view if you choose to, okay? Now, Kubernetes, when it first came out, was advertised as a platform on which to build other platforms. But as we all know, or those of you who use Kubernetes know, Kubernetes became the platform that people talk to directly. Now, Knative is being advertised as a platform on which to build a serverless platform or a platform as a service platform, right? You're not necessarily meant to talk to Kubernetes or Knative directly, at least that's what they're advertising. Whether that plays out for real in the future, who knows? But for right now, a lot of people do talk to Knative directly, so it is still in this mode of it is the platform people will talk to when they start wanting to deploy these simplified applications. Okay, so let's talk a little bit about what Knative actually is under the covers. Under the covers, Knative has two main components. First is serving, and as the name implies, serving is the environment or the component that hosts your application. Very, very simple, meaning it uses Kubernetes pods under the covers, just presents it to you in a very simplified fashion. The second component is eventing. Now, eventing basically allows you to manage those events that come into the environment, because remember we talked about serverless and functions, right? They're supposed to be event-based, right? So as the events come into your environment, you may need to manage those events beyond just deliver it to my service, right? It may be, oh, I need to possibly persist it into some sort of queuing system because my service may be down for temporarily doing something, or maybe I need to have it fan out and get sent to many different services, right? Whole bunch of orchestration type things. Eventing gives you the basic building blocks to actually build up those workflows. We'll talk a little bit more about that later. So let's dive a little bit deeper into Knative serving, since that's the heart of Knative. Now, Knative introduces the notion of a service or a Knative service. Don't confuse that with the notion of a service in Kubernetes, which is more like an endpoint, right? Knative service is basically your application. Now, within your application, what you're going to have is versions of your code, right? Meaning versions of your application. Each version has associated with it a configuration. So as you make changes to the configuration, whether it's to change the Docker image that's being used or change some configuration parameter, that's going to be associated with that particular version of your application. Now, once you deploy that version or revision, Knative is going to set up an endpoint, meaning an external URL that a user can now hit. So it's going to set up the networking for you automatically, right? Simplified user experience. All you did is give it the application. It starts doing all the magic under the covers for you. Now next, as the application gets hit from the end user or through whatever system is sending events to it, it will scale up versions of the application. So it will scale up, to create, in this particular case, 3 different versions of revision 1 based upon the amount of load coming in. And I get to control how quickly or slowly things scale up and down. And again, as I mentioned earlier, because this is kind of serverless and function based, or they're stealing a lot of ideas from there, it will scale down to 0 if no one ever actually calls that version of your application. Now next, when you choose to roll out another version of your application, and by the version I mean you've changed the container image you're running, or you've modified the configuration file, Knative will treat that as a completely new version. So it'll create, in this case, version 2, and then it will slowly route all traffic over to version 2. And eventually version 1 will just go away, right? So it does this automatic rolling upgrade for you. Again, you don't have to do anything manually yourself. It does it all for you. However, if for some reason you do want to actually have 2 different versions of your application out there and you want to do some sort of traffic splitting, so for example, as I'm showing here, you want to have 90% of the traffic go to version 1 and 10% go to version 2 for a while, so you sort of test it out to see whether it actually works. You can do that. You can ask Knative to do that for you in a very simplified fashion, and I'll show you how to do that in a demo. Now this picture here shows traffic splitting based upon percentage based, and that's all you can do today in Knative. There is work going forward so you could do traffic splitting based on other things, but for right now it's basically just percentage based. Okay, finally what you can also do is set up a dedicated URL for a particular version of your service. Now, look at the top part of my picture, right? I have a single endpoint. Where's my cursor? Oh, I don't have my mouse. Okay, anyway, the top little green endpoint box, that represents a single endpoint that's sort of in front of version 1 and version 2. You could think of that as the main entry point to your service, and Knative will manage that for you. However, let's say I have a situation where I want to create a version 3, which is really, really new code, completely untested. I don't want anybody to hit it except my testers. What I can do is I could tell Knative to create another version by giving it a new Docker image as an example. And I'm going to configure it in such a way that I ask for a dedicated endpoint just for that one, but to then also exclude it from that main entry point, meaning exclude it from that routing, percentage based or not, from the above picture. Okay? That way my testers will know about that dedicated endpoint and they'll hit it and they'll be able to test it for me, but the rest of my user base will still be using version 1 and version 2. Okay? And that's basically the main points of what you can do with the Knative serving model. And the key thing here is that Knative will manage all of the resources under the covers to do this for you. Now, because some of you who may understand Kubernetes knows, or you guys know that in order to make this happen, there are a lot of resources that have to be created, right? You have endpoints, load balancers, Kubernetes services, pods, replica sets, all this other stuff that has to be created. As a Knative user, you're not exposed to any of that. I'm only exposed to the Knative service. That's it. There are going to be configuration options on there, so I can control things like the percentage base routing, asking for a dedicated endpoint, but that's all within the scope of this Knative service. So you have a very simplified user model being exposed to you. All right, so a couple of things to understand about Knative serving. First, because Knative serving assumes everything is event-based, you must have an HTTP server running within your container, right? So this notion of start a container that just does some work and then it's done doesn't really exist, right? Everything has to be initiated through an HTTP connection coming into your service. Okay, that's why you have to have an HTTP server running there. Next, everything is multi-threaded by default. Notice when I talked about that container concurrency, right? I set it between 0, meaning infinity, and 1. It assumes, because you have an HTTP server running there, that the HTTP server will spin up threads, and each thread will process, one request, and that's what I mean by a multi-threaded model. However, as I showed you, it is configurable. So if for some reason each instance of your application, meaning each pod, can only handle one request at a time for some reason, you can set the container concurrency down to 1, just like I showed you in the very beginning of the demo, right? That's perfectly allowable. So that makes it act more like a traditional single-threaded application. That's perfectly fine. Now, there are some configuration options. I showed you some of those, right? Container concurrency was the one I showed you. There are also min, max, and target scale options, right? So you can tell Knative the minimum number of instances that you want running. So for example, you can actually override the scale down to 0. Right? Let's say for some reason you don't want it to scale down to 0, right? You want one instance there always ready to go. You don't want to have even, a millisecond of delay while it spins up on that very first instance. You can set the min scale to 1. That's allowable. You can also set the max scale. So let's say you only want maybe 5 requests per instance of your application running. You could set it to be 5. That's allowable as well. What you can also do is set a target scale, meaning asking Knative to try to keep the number of requests per instance to this particular target level. That way he doesn't necessarily spin up, 10 different pods all doing just one request, right? Because technically he could if he chose to, right? There's no reason why he can't. But if you say, no, I want you to try to get 5 requests per pod, what he'll try to do is he'll try to keep each pod at a steady level of 5 requests, and then he'll scale up and down based upon that request. Okay. Now you can do scaling based upon CPU or number of requests, right? So if you have a low number of requests into the system, but your application is very CPU intensive, you can control the scaling based upon CPU. That's another way to manage things. Now, in the demo, I showed you Knative through this very simplified command line experience. For those of you who maybe still want to use kube control with YAML, you can still do that. But notice, while the YAML on the right-hand side is a little bit verbose, I put into bold just the 2 bits of information you needed to make this actually work, meaning the name of the service and the container image, right? Everything else is just basically noise, right? But you can see, compared to what you'd have to do with Kubernetes, this is much, much simpler, right? All you're doing is giving the name and the container image. All right, so with surfing behind us, let's now talk about eventing. As I mentioned, eventing at its core is really just a set of basic primitives to help you manage and do the coordination of events coming into your environment, and obviously then being delivered to your Knative services. So let's take the most simple basic case, right? You create this notion of an event source, which is really nothing more than a utility function that connects up an event producer to a service. Now, what ends up happening is when you create an event source is you tell it what producer you want the event from. It will, in essence, do a subscribe to that event producer for you. You then also provide it what we call a sink, which is the destination of the events, right? In other words, which Knative service do you want the events to go to? And then it also deploys this thing called an adapter, which technically is the thing that receives the events from the producer. Now, the reason that's in there is because the adapter is actually going to convert this thing into a cloud event. For those of you who are familiar with it, there's a specification being developed by the Cloud Native Computing Foundation called Cloud Events, which tries to standardize the metadata inside events so that if you want to do some middleware processing, such as filtering or routing based upon things like who produced the event, Cloud Events defines that common bit of metadata and where it goes into a message so that you can have middleware do that filtering and routing without necessarily having to understand what the actual business logic of the event is all about, right? So you don't have to have a specialized router for every type of message coming into the system, right? It kind of normalizes all that metadata. And that's what the adapter basically does for you. But aside from that, you can think of it as nothing more than a proxy, okay? Now, with that basic notion, though, what you can now do is add other things into the picture. So, for example, you can add a broker. If you wanted to have something that sits in the middle, for example, an event queue, because maybe your service might come up and down, or you may have some downtime with it, you can put a broker in between the two, which may or may not have some persistence if you want, right? If you want to have a highly available system, you probably want some persistence in there, just like a queue. And you can then connect up your service to the broker. Now you connect it up by creating what we call a trigger. Now the trigger is almost like a little subscription, right? Your service can say, I want to subscribe to this broker, but you can also specify filters because maybe the broker is receiving events from many different event producers, but maybe you only want to see certain events of a certain type or from a certain producer. You can filter based upon a whole bunch of different criteria but that you ask the broker to do the filtering for you, right? But again, this goes back to the cloud event stuff because everything that comes into the broker is going to be a cloud event. The broker doesn't need to know what type of event it is. It just needs to know that, oh, the service wants to do a subscription based upon maybe the type of event coming in, and the type field is a cloud event defined type. The broker knows how to find that because it knows where to find that in the cloud event metadata. Okay, basic pub subtype operations here, very simple. But finally, if your service happens to have a return message from the incoming event, that will go back to the broker, since the broker is the one that initiated the request, and you can now tell the broker where to send that response message. Maybe nowhere, maybe onto another broker, maybe onto another service, completely up to you, completely defined. So again, this is all about the basic building blocks on which you can now develop a fairly complicated eventing coordination or workflow system. Okay, now those are the basics of the system. However, there are a couple of newer type features that are available that you may find interesting. One is a sequence. So rather than just having one event come in and go to just one service or even get fanned out to more than one service through a broker, what you can do is have that event go through a series of services or syncs, and the system will automatically route from one to the next, right? So this is basically using those building blocks from the brokers and triggers and stuff under the covers, but it just allows you to specify it in an easier fashion. Like that way you don't have to create a brand new broker every time you maybe want to set up a new sequence just to tell it where response messages go. Another choice is, or another choice is called choice, right? Where one incoming event comes in and it will get routed to more than one sync. But you can also specify a condition in front. The same way you can specify a condition or a filter mechanism when you do a subscription to the broker. Okay, so again, these are all just convenience functions, so you don't have to set up the brokers and system manually under the covers. Now, when this thing is done, you can tell where the final result of the choice goes to or the final result of the sync goes to. Okay, so sequence is just a series of services, while choice is more of a fan-out type of a thing. Okay. Now, there's also an event registry, which allows you to basically have a single place in which to query to find out all of the brokers that are in the system, if you want to know where you can subscribe to in the system. What are the event types that the system knows about based upon the event sources that have been defined into the system. So for example, let's say I want to subscribe to GitHub to get events from my GitHub repo. I may not necessarily know what all the various event types that GitHub is going to produce. I can ask my event registry that information because it knows about a GitHub event source because that's part of the system itself, right? So I don't have to go off to the GitHub documentation to find this information. I can look at my event registry to know how I can subscribe, how I can filter, that kind of stuff. And finally, we have the cloud event specification itself. Already talked about that, but here's a URL for you if you want to find out more information. Now, so that very, very quickly showed you Knative serving, Knative eventing, which is at the heart of what Knative is all about. So let's go back to this matrix of all the various features of these various options presented for you or presented in front of you. So with Knative, my assertion is that pretty much it does everything we talked about in the past. Now, of course, with a few caveats. In particular, these WIPs, these work in progress ones, right? Let's talk a little bit about those. Build is not part of Knative. Now, Knative actually used to have a build component. They actually ended up removing that. What they did is they spun off a brand new project called Tekton to actually do builds. Now, while that's not going to be part of Knative proper, what you should see in the not too distant future is Tekton integrated into the Knative command line. So if you deploy Tekton along with Knative in your environment, which most people will probably do, you will be able to have build for you, right? So the fact that it's not technically part of Knative won't matter to you as a user. You just know it'll be in the system. That's not there yet, but it will be soon, hopefully. Now, advanced features, networks volumes. Again, because Knative uses Kubernetes under the covers, you can get to those things if you really wanted to by going around Knative if you chose to. So the answer to that is yes, you can do it, but it's not there as a first-class citizen in Knative. They're thinking about adding it. They haven't done it yet, but I do think they will start adding some of those as we go forward. Asynchronous invocations. Not there yet today, but we do plan on adding that at some point, at least from the IBM perspective, because that's another use case that we care a lot about. Non-restricted execution times. That's another one that isn't there today, but we will add in the future, meaning you'll be able to bring up scalable services that can scale down to 0, but as long as they're processing a request, they'll stay up indefinitely, just like any other pod, right? So while not everything's there today, my assertion is that eventually all the features that we talked about before should be available through Knative, which means you as an end user no longer should have to choose between which of the various as a service platforms to choose from, right? You don't have to say, do I want containers versus platform as a service versus function as a service? Knative should allow you to do all of those all in one. So you can no longer, or you should no longer have to worry about which name to call your thing, right? Just think about deploy your application and just turn on the various features or off the various features that you want or don't want. The choice is yours. The platform gives you all the flexibility you need, right? And that's wonderful. So as I said, you get the best of all worlds with the simplified user experience, but you still have Kubernetes under the covers. So you still have the full set of Kubernetes features available to you, some available through Knative, others if you really want it. For the edge cases, you can go around it to get access to Kubernetes if you really need to. The point here is that as a developer, the decisions facing you should no longer be which platform to use to deploy my application. You can now go back to focusing on your application itself, whether that's coding or figure out how to architect your application. Figure out the size of your containers, where the boundaries are between your functions or your pods, however you want to think of them, how you want them to scale, stuff like that. Basically, the architecture application or the coding application is what you should have to focus on, which is what you should only really care about, right? When it comes to the architecting the application infrastructure, let Knative handle all that for you. So, because I'm an IBMer, I feel like I have to explain to you a little bit more about what we offer from an IBM perspective. Now, we, IBM, are very much involved in Knative. We're very much involved in all the various aspects of it, including Tekton. We do offer Knative as an add-on to our IBM Kubernetes service, and it's a one-click install. Meaning, if you look at the UI, you'll have a single install button. And it will install Knative as well as Istio under the covers. And from the command line, if you prefer command line stuff, with a single command line, you can basically enable the Knative add-on, just specifying the cluster you want, and it will install everything under the covers for you very, very quickly. So we have a very simplified install sequence for you. While the Knative add-on today is in experimental mode, the experimental aspect of it is a statement about the Knative code itself. Because as I pointed out before, there's still many things that are work in progress. So we don't feel like it's quite GA level yet, but we'll get there soon. So the experimental refers to the maturity level of Knative itself. Relative to the code being hosted by IBM on your behalf, it is managed for you, so you don't have to worry about that. As new updates of Knative come out, as you ask us to, we'll upgrade the Knative infrastructure automatically, so you get the newest features automatically. You don't have to do anything special yourself. And it should be basically zero downtime for you. If you want more information about it, you can find out about it at ibm.com/IKS. And with that, thank you very much for your time. If you have any questions, please don't hesitate to reach out to me, either through Twitter or my email. Okay, and thank you guys very much.